Weeks of St. Mary's Correctional Center. I'm continuing on our series, sharing some of my experience and just some pointers in geometry, and that you may run into on the task test for something similar, maybe an employment test, maybe little quick things. Make sure an adult would know for job skills and stuff. All right, so I've talked about angle relationships and line relationships in Geometry 1 and some topics. Geometry 2, I'm going to talk about polygons, okay? And some types of polygons. I'm not going to dwell on all of them, but you can look at them. There is the names for 3-sided, 4-sided, 5-sided, etc. Okay? But a polygon is a shape made up of straight sides, can have a curve, and they must meet at a vertex. Okay? I'm going to talk about triangles first. Obviously, it's the first polygon. And so the triangle is formed by 3 segments that meet together. A couple things that I will also talk about. Equilateral triangles, all 3 sides are congruent or the same length. Isosceles, you only have 2 sides that are same length. You can look at the other vocabulary words, but it's not something I'm going to focus on today. Okay, taking a peek at a triangle. One of the first things we want to look at with relationship to the triangle, if I would take a triangle, and let's say I could take this apart, unhinge it, and let this flop over and it was on a hinge, you can see that we could drop both sides down and end up making a straight line. Okay? As I've just discussed before, a circle's 360 degrees, a straight line cuts it in half, so as we proved in the earlier video, a straight line is 180 degrees. So if a triangle can be dropped down to form a straight line, then in theory we have shown that all three angles formed would add up to equal 180 degrees. Okay? So angle 1, angle 2, and angle 3 could add up to equal 180 degrees. And that is called triangle sum theorem. Nothing you need to know. What you need to know in a test is how to come up with an answer if they give you a missing angle. And here's an example. So now that I've showed you that all 3 angles have to add up to equal 180, which problem would represent how you would solve it? And hopefully after you take a second to look at it, you'll realize that angle 1 plus the 40 plus the 75 must equal 180 degrees, so your solution would be B. Okay, moving on. Well, what if I have to solve for it? So I know that all 3 angles of a triangle is 180, and so then I'm going to subtract the ones I know to find the one that I didn't know. So 180 minus 30 minus 20, okay, and 30 and 20 is 50, and 180 minus 50 would be 130 degrees. So angle 1 would be 130 degrees. Okay, over here 75, 35 would be 110, so 180 minus 110 degrees. So taking 180, subtracting the 2 I know to find the one I don't know, and you're missing angle 70. And here's an example of an equilateral triangle, because as you saw in the vocabulary, an equilateral is also equiangular. So if this is 60, this is 60, 180 minus 120 is 60. So 3 60s are 180. That's an example of your equilateral triangle. Okay. Now, here's one of my favorite theorems, little tricks. It's a shortcut, but you will see a problem like this. Okay, so now I know that all 3 angles on the inside have to add up to equal 180. So 180 minus the 2 I know, and they totaled 140, left me the one I didn't know, which was 40 degrees. But they're not looking for the interior angle or the angle on the inside. They're looking for an exterior angle or the angle on the outside. And if you remember from the last video, a linear pair of 2 angles that, okay, 2 angles that their non-shared sides form a straight line must add up to equal 180. So 40 plus what? Equals 180. Okay? And so you can take the 180, subtract what you know to find, and cut across. All right? Now I'm going to come over here real fast and see if you see my trick. Okay, see if you see my trick. This outside angle equals 75 degrees. Okay, and this outside angle equals 140 degrees. All right, I'm not that quick. I'll teach you my secret. If you noticed, 180 minus the 2 I know, right, leaves me this. Well, this has to also equal 180. So 180 minus 40 gives me this. 180 minus 40 gave me that answer. So if you forget the shortcut, that's all right. You can do it in 2 steps. But if you notice the relationship, the 2 on the inside always equals the 1 opposite on the outside. So all I did over here was added these 2 together and knew it was the one on the outside that they weren't touching. But if you did it the long way, 180, right, minus 75, right, left me 105, so this one's 105, and then 105, 180 minus 105 would have gave me 75. So hopefully you saw how I got that trick, and why do I like this one the best? Because it's called exterior angle theorem, and as you can tell, EAT is something I like to do. Okay, not getting real complicated, trying to show you a little trick so you can start understanding how this next theorem comes about. If I have a length, side length, and excuse my drawing, and I was at a distance, and I had to make an angle to close it, in other words, this side length, I take an angle to close it to make a triangle, and now I'm the same distance away, but I have a longer segment. You notice my angle is going to change in relation. So in a sense, the length of my side determines the opposite angle, how big it is, or my angle can sometimes determine the size of my angle can help determine the size of the length. Well, where does that come in effect? For an isosceles triangle, remember a triangle that has 2 sides that are congruent or the same length. Well, if this side length helps determine the opposite angle's size, and now this side length's the same, and it only makes sense that this angle must be the same measurement. Okay? So we can use that. Here we go. It says find the measure of A, and I see they made marks tell me these sides are congruent, so the opposite angles are congruent. So if this one's 45, then that one's also 45 degrees. Not making it real complicated, that's all they're trying to get you to see and recognize and go to quickly. It's called base angle theorem, and you'll see in the vocabulary. Here we have a triangle. We don't know all the side lengths, but oh, wait a minute. We see that these 2 angles are congruent. So the base angles, base angle theorem, are congruent, so that opposite side must also be congruent. So if this side length is 20, then x is at 20. Okay? And I'll just pause for a second, or you can take and pause and read this. And that's what I was just showing you. Base angle theorem, if 2 sides of a triangle are congruent, then their opposite angles are congruent, and reverse. Obviously, if it's equilateral, then all 3 sides are congruent. All 3 angles would be congruent. Okay, so putting that into practice, here I go. I see this is 108. Well, I know that 180 minus the 1 I know would leave me 72 degrees. And obviously these 2 angles are the same, so it must be an isosceles. And so to make them the same, I would just divide by 2, and each one of these would be 36 degrees. So there would be an example how I'd use that knowledge to solve a problem. And here with equilateral, equiangular, okay, all 3 must be the same, 60, 60, so this must be 60. So I would set an equation 3x equals 60, divide both sides by 3 to isolate my variable, x equals 20 degrees. Okay, so there's putting some of those theorems into practice. Okay, we have other videos of Pythagoras theorem, but since we're dealing with polygons and I was taking a look at triangle, another opportunity to take a look at it. Okay, If I go a little bit quick, then I'll try to do my best to explain it. If I go a little bit quick, go back and watch other videos of Pythagorean's theorem. But remember, a squared plus b squared equals c squared. Okay, so 6 squared plus 8 squared equals c squared, or 36 plus 64 equals c squared. And so 100 equals c squared. But I don't want c times c or c squared. I just want the length. So that to undo the square, you take the square root. And the square root of 100 is 10. Okay, and this one, a squared plus b squared, or 5 squared plus 12 squared equals c squared. You see this word hypotenuse? Hypotenuse is always your longest length. And you're always going to find that across from the 90. So these are your legs, or your short sides. So your A's or B's, it doesn't matter which one you call A or B. But C, your angled length has to always be C. Okay, so just making sure you clarified that. 5 squared is 25. 12 squared is 144. Add these together, it's 169 equals C squared. But I want just C, so I'll take the square root. The square root of 169 is 13. Okay, so this length is 13. Okay. All right, if you notice this time, we're missing a leg. Okay, but they're giving us C. All right. So I would still set it up. 10 squared plus b squared equals 26 squared. This is 100 plus b squared is 676. So I want the b by itself, so I'm going to subtract the 100 from both sides. What I do to one side, I do to the other. So b squared equals 576. And this, take the square root, and the square root of 576 is 24. And yes, I cheated a little bit before I started shooting this, so I didn't do all that in my head. All right, and again, a squared plus b squared equals 15 squared. Now these are some numbers I am familiar with. So a squared plus 144 equals 225. I'm going to subtract 144 from both sides. A squared equals 81, and the square root of 81, a equals 9. Okay. Real quick touch back. One way teachers, I remind my students when they're doing Pythagorean theorem, when we're doing Pythagorean theorem, if I have the two sides that are touching the 90, then I'm always squaring them, adding them, and then taking the square root. So when they meet, I got the legs. You notice I'm always adding and then taking the square root. When I have the long side and only one of the short sides, you're always squaring them, and then you're subtracting the smaller one from the larger answer, and then taking the square root. So it just helps, a little trick mentally to remind my students, okay, which step to do, whether to add or subtract before they take the square root in Pythagoras theorem. All right, I did all that because the distance formula, and I'll show that to you here in a second. But they're asking us the distance formula, and maybe you'll get a graph, or maybe you'll just get a couple points on the graph, and they want to know the length. And if you notice the distance formula, it's all kind of one bunch of variables and stuff, and students tend to get confused. So from teaching geometry, I would get students to do this. Wouldn't it be nice, you know, it's no problem to tell how long that line is. It'd be 1, 2, 3, 4, 5 units. And it's no problem to tell how long the distance of that line. 1, 2, 3 units, if I could draw. Okay? But what happens, Coach, when it's angled? When it's not just going left or right, or it's not going straight up and down where I can count it. So, well, I am going left and right. So how far left and right did I go? 1, 2, 3. Right? So I went left and right 3. And how far up and down did I go? 1. So I went 1 up and down. And wouldn't it be nice to know that that distance? Well, look at what we just created. We just created a right triangle, so we can use Pythagorean's theorem. So 3 squared plus 1 squared equals this longer length, c squared. I'm just going to change it to d. The distance, you can call it d squared. Okay? And so 3 squared is 9. 1 squared is 1, is d squared. And so d squared would equal 10, or the distance would be the square root of 10. Okay? So it'd be a little bit over 3, approximately about 3.1. But you could punch that in your calculator and figure it out. So let's look at this again. I want to find my distance. So I'm going to go over 2 and up 2. So a squared plus b squared would be my distance, or c squared. Okay? And 4 plus 4, all right? Or this answer would be whatever the square root of 8 is. Okay? And you can do the same thing here. Your x distance is 4, your up and down is 2, and put that in Pythagorean's theorem. And here, I've given you an example. You can freeze frame it. If we just changed, we're trying to find the length, and there is your distance formula that you will find on your task sheet, right? The distance equals the square root of all this stuff, and basically what have I done? How far apart were the x's? How far apart were the y's? Right? And then we did what? A squared plus b squared, right? And added them together, and then we had to do what? Take the square root. Okay? So basically that's all we're doing. And don't let that, you mathematicians, confuse you with it being one big formula. It's just a process. Okay? So over here, 1, 2, 3, 4, 5 across. 1, 2, 3, 4 up. So you could use 5 squared plus 4 squared, do Pythagorean's theorem. I'll let you work that out. All right, but here's what I want to show you. What happens if they just give you 2 points, and we've seen this on a test. They give me 2 points in the graph, and coach, distance, how am I going to find that? And I'm looking at that formula, okay. Remember, in an ordered pair, I go x, y, x, y. So how far apart are my x's? Okay, so I can do it a couple ways. 1 minus -2, right? So 1 minus -2, negative and negative touching. So that becomes 3, all right? And 1 minus 5 would be -4. So if I go 3 squared plus -4 squared, 3 squared is 9. A negative and negative becomes positive, so it doesn't matter. There is no negative distance. That becomes 16. All right? And 9 plus 16 is 25. And remember, we're saying that's the distance squared, or c squared. So I take the square root to get d, and 5. So the distance between 1, 1 and the point -2,5 on the graph, if you would graph them and do what we were doing before, you would see it's 5. Okay? I will show you or talk to you the same problem real fast. I also tell my students, if I'm at 1, how far is it to get to -2? Well, from 1 down to 0 is 1, and down to -2 is 2 more, so I'm a distance of 3, right? And if I'm at the 1 mile marker and I'm going to the 5 mile marker, I'm at the distance of 4. And sometimes students see that easier than doing the subtraction and messing with the integers. And so you'll see I end up with 3 squared plus 4 squared is going to equal c squared, or my distance, well, I'm trying to solve. And you still end up with 9 plus 16 equals c squared, or 25 equals c squared, square root, c equals 5. All right? So using that little trick, I'll do this problem. Let's look at our xy's, xy's. So how far are my x's apart? 5 down to 0 was 5, and on down to -2 was 7. So this distance, the distance left and right, was 7. All right, my y's, I was at -1. It takes me 1 up to 0, 3 more up to 3, so I'm a distance of 4. And so now my left and right is a distance of 7, my up and down is 4. So how far did I travel? between R and S? Well, you're going to have to plug it in the Pythagorean theorem and solve. So that'd be 49 plus 16 equals c squared, okay? And 15 carry the 1. So 65 equals c squared. Take the square root. So the square root of 65 is what? Well, 8 times 8, 64. So it's going to be approximately somewhere close to just a little bit over 8. Maybe 8.0 something, okay? So there's an example, students and teachers, how to plug stuff in using Pythagorean theorem, which is basically the distance formula. All right, a little add-on here, a good activity. A triangle. If I had lengths 2, 4, and 6, so you maybe had straw 2 inches long, 4 inches long, and 6 inches long, could you make a triangle? All right, well, if I had something 2 inches long and I stuck it right against something that was 4 inches long, right, and then I had something that was 6 inches long and laid it side by side, we would agree that they would be exactly flat against each other. How can I make a triangle? Because to make a triangle, I have to go out a little bit to come back in. So just a little known fact, I don't know if you'll see it test in a task test, but some other general knowledge tests. This is kind of one of the little common knowledge trick questions for triangles. They'll ask you, can I form a triangle? You must be able to take the two shortest sides and add them together, and they have to be larger than the other side. Now, as long as it does that, you can make a triangle. What kind of triangle we're not concerned with today. So 2 plus 4, is it greater than 6? No. So you can't make a triangle out of these 3 side lengths. 10 plus 10, 20. So yes, I can make a triangle. And 5 plus 7, 12. Yes, I can make a triangle. Okay? I know that's something not directly with the task, but I wanted to share that, put that in here. All right. I'm not going to cover all the quadrilaterals, quad, 4-sided. Polygons, but some general knowledge and a few tricks of the trade and stuff I want to talk about. Okay, we know that a square and a rectangle have 90-degree angles, 4 of them. Okay, and we know that a square not only doesn't have to have 4 90s, all the side lengths have to be the same length. So if you knew that, if I told you this was a square and I gave you some kind of algebra problem, then I would know if this side is 8, then x would have to also equal what? 8. And this problem, and a little bit more different. So y minus 5 would have to equal 8. And to get to y by itself, I add 5 to both sides. So y equals 13. Okay? Something that a lot of, some of you that have worked in construction or carpenters and stuff would know, a little trick of the carpenter's trade, they know to check to see if a building's straight, they know that the diagonals of a rectangle are the same measurement or same length congruent if a building's square. In other words, all 4 sides are 90s, which is what's required to be a rectangle. So that's one little trick. One thing we sometimes forget, though, is these also intersect or bisect each other into 2 congruent parts. So if this length is 5, then this would have to also be 5. So x minus 1 equals 5. Add 1 to both sides. All right, so x would equal 6. And you can do the same algebra here. A rhombus has all 4 sides the same like a square. The only thing different is you can see it does not have 90s. So a rectangle has all 90s like a square, but it doesn't have congruent side lengths. A rhombus, or ladies like to call it a diamond. Husbands, make sure you buy your wives big ones. But a rhombus has all the sides the same, but they don't have 90s. But, a little trick here, rhombuses, when they do, the diagonals do still intersect each other. This one is bisected. So these 2 sides would be the same length. These 2, if you ever saw a problem. And a little trick, they also meet at a 90. Okay? What they're asking us here is if this side length's 10, then what would this be? That would also be 10. And x plus 4 would equal 10. So x would have to equal 6. Okay? So just a few little tricks of the trade and some problems you might run into. What was the value of x? Well, we know that a rectangle has to have 90, so 3x equals 90. Divide both sides by 3. And so x would be 30 degrees. Here's our rhombus. which is a type of parallelogram. Opposite sides are congruent. So I could just say 6x equals 18. I want to get the x by itself, so the opposite multiplies divide. So I divide both sides by 6, so x would equal 3. And here, I think the original problem that I had for my students was, is this a parallelogram? So no, the opposite angles aren't congruent, so it wouldn't be a parallelogram. But we do know that a quadrilateral has to all of the sides add up to equal 360 degrees. So if you took 360 and subtracted all these ones you know, okay, 108, 104, so what is that, 212, right, 12, 18 carry, so what is it, 288, my brain's hurting today, 360 minus 288, so it'd be 72 degrees. So this angle over here would be 72 degrees. Okay? And that leads me into this. Okay? That segues me to this. Just a quick example. The red interior means you're on the inside of a polygon. So interior angles would be the measures on the inside of any polygon, whether it's 3-sided, 4-sided, 5-sided. Okay? Exterior angles are on the outside. Okay? Exterior angles are the blue ones on the outside. Polygon interior angles theorem. You'll see the theorem is basically this. What if I ask you what is a missing degree measurement in a polygon? And here's the formula. Take the number of sides, subtract 2, and then multiply by 180. So let's take a triangle. How many sides? 3. Minus 2 is 1. Times 180, and yes, we already proved that a triangle, all 3 angles add up to equal 180, right? A square, right? 4 minus 2 is 2, times 180 is 360. Well, we know that a square has 4 90s, right? So it's 360. So what about a 5-sided or 6-sided? You're not going to have to remember. The formula you'll run into, just take the number of sides, subtract 2, multiply by 180. All right. So here, 1, 2, 3, 4, 5 sides, minus 2 times 180. All right. So that's 540. And if you subtract 76, 112, 92, and 120, or you add them all up and subtract them, then you would find that this angle measurement's 140 degrees. Okay. Let's look at this one. 1, 2, 3, 4, 5, 6. 6 minus 2 times 180. Okay. Which is 4 times 180. And you'll find out that's 720 degrees. So all these angles added up must equal 720 degrees. Well, 1, 2, 3, 4, 500. 580, 600, so add them all up at 600 degrees. 720 minus the 600 we know leaves us 120, and so angle 1 here is 120 degrees, and 4 minus 2 is 2 times 2, or 2 times 180 is 360, and we already knew that this would be 360, all right? And 360 minus the ones we know, and I'll let you double check me with your calculators, but that would be 109 degrees. Okay? So, some things that we talked about. All right, real quick, this one's real quick. Polygon exterior angles theorem. One thing you're going to realize, all the angles going around a figure, going right, what? We're going to add this one, plus this one, plus this one, plus this one. If I took this angle plus this outside angle, and that outside angle, and that outside angle, and that outside angle, I'm going what? Around that polygon. No matter how many sides, you're always going to add up all the outside angles to go around it, which we're making a what? That's right, a circle. And a circle has how many? 360 degrees. So basically, that's what it's saying. No matter how many sides you have, all your outside angles will always equal 360. So just like we were doing before, except for now you don't have a formula n minus 2, you don't have to do any of that extra math, you just start with 360, subtract the ones you know, and find the ones you don't know. And if you add all these up and subtract it from 360, in this problem, you should end up with 70 degrees. And over here, I kind of messed it up. That's 117 right here, 57, 59, and 85. Add all them up and subtract them from 360, and 1 would be 42 degrees. Okay? So, any questions? I hope not, but if you do, just you or your instructor can ask. Call me at St. Mary's Correctional Center. I will do. All right, I've talked about this in ratio or but one of the last things that you'll be tested on quite often dealing with polygons is similarity, or they'll give you a missing length. Okay, and so I just wanted to throw this back at you. If you're a little confused, then go look at the ratio proportion video that I have posted on the help desk, and you'll see how to work cross products and solve. But an example, are these two proportional? So that makes them similar. So you just pick, so I'll say 20 is to 15 as, say, bottom to bottom. So bottom of the big is to the bottom of the little. Okay? And 920s are 180. Okay? And 15, so that's 2, 6. So 15 and 15 is 30. 12 would be cut in half, be 6. So that is 180. Sorry. Should be a little faster today now. So since they both are congruent when I cross multiply, okay, then I find out that yes, A and D are proportional or similar. Okay. If you notice on a square is 4 to 5. Like 4 is to 5. Well, I hope you wouldn't even have to do any math that you're going to see. So all squares are similar, all right, or proportional. Okay. Rectangles you would have to check is 4. Okay, 4 to 4, the same as 6 to 3. Right. 4 times 3 is 12. 6 times 4, 24. So no, these two, you cross multiply, did not come. So these two rectangles, although they're both rectangles, they are not similar. Okay? So, just, I'm not going to do all the problems. Again, if you're still a little fuzzy, go back and look at the ratio proportion video that we've prepared for you. Okay, I'm going to wrap up this part of Geometry 2 and some of the top topics I talked. Giving instructors some hands-on activities, so they can develop these theorems with with their own thinking or whatever. One thing is here, have them cut out. It doesn't matter what side. Take a straight edge now and make a triangle. Have them cut it out and then just rip the corners off. Okay, your triangle, and see if you can place all 3 of the sharp edges, not where you tore. The sharp edges of your triangle, see if you can add them together. So I'm taking angle 1, plus angle 2, and plus angle 3, and see if they fill in a straight line. And you'll find your students can get together and do that, and they can all make different triangles, and every one of them should be able to piece theirs like a puzzle together. And so there's just a chance to prove that your 3 angles add up to equal 180, a nice hands-on activity that you can maybe introduce a lesson with and catch their interest. And here's another one. Take graph paper and have them make a right triangle, and then make them square, right? Area length times width. Well, if it's the same length, so it would be that side squared, or A squared, and B squared, and C squared. And then let them count how many blocks and how many blocks and add them. And then they would have to shade in the whole blocks and then piece together 1, 2, 3, 4 for it. And anyway, they can visually just count and see and prove Pythagorean's theorem themselves. Again, another maybe way to help someone that's having a harder time with the math and understand why we're squaring and taking the square root back and stuff like that. So a couple of exploration activities that I thought I would share with you today. All right? My last video on geometry, folder is going to be Geometry 3, and you'll have a lesson on basic trig. And then I'm going to cover some of the circle problems, some intended angles and stuff in a circle, and just show you where some of the formulas come from for volume, surface area and volume. I'm not going to work on all the problems. Other teachers have done some problems, so I'll limit that. And hopefully this would give you in your classroom or students that are watching this a chance to basically cover what I think are the key questions you might run into on a task test or maybe an employment test or whatever like that that's commonly tested. I thank you for your time today and watching this video. Again, just give me a call if you have any questions.